Good afternoon, everyone. Please let's give Dr. Francis a moment. He'll be joining us soon. Thank you. Good afternoon, Dr. Francis.
Yeah, good afternoon. How are you?
Thank you, sir.
You check your message.
Sir?
I said, you check your message. You want to drop on Zoom?
On the group.
On Zoom. Check the Zoom chat.
Zoom. Oh, Zoom.
All right. We wait a bit. That's it. Welcome. And for those of us who are here, so where do you guys want us to start from? Hello.
Hello, good afternoon, Dr. Francis.
Good afternoon. How are you?
Fine, thank you.
So where do you want us to start from now?
For me, I think at least Power BI is just the area I'm having a little challenge. And then maybe if you can just also brush us through maybe just some advanced Excel. I don't know of others, but for me, I think if you can start with Power BI, and then
For now, that I think we're already done with Power BI. So did you try to watch the videos?
yes, I'm going through the link. I saw the videos.
Yeah, so what I want to know is that what I'm asking, because where we are in Python is a bit more on the machine learning area. So either you want us to, because for those of us who have just joined, and maybe we are not clear with all the tools. So either we just brush you up from a bit of the Python, or you want us to start from more like the foundation of the Excel, so that before the other members come, at least you'd have had some things you want to learn. But Power BI, I don't know. I don't know about Power BI yet. But if others are interested in it, then that's fine. But I just want so that there'll be consistency. That's why. If not, I don't mind taking it, but it's just to ensure for consistency.
Okay, I think for consistency, let's just take almost everybody has some
Sorry,
ideas about
your
Excel.
line is weak. I didn't hear you properly.
So I think it's easy in managing our time and for efficiency,
Yeah.
to look at that again and then build on that.
Sorry, which one?
Then while we go back to look at the record,
Sorry, I didn't hear what you said that initially.
I'm saying that it may be useful to build on Excel, since almost everybody has a foundation on Excel. Then we can build on that while we go back to.
Okay. So
Sorry?
what you are suggesting
Might
is
be.
start the foundation from Excel, then gradually we build that up. Is that what you're saying? Hello?
Yes, for sake of a systematic approach.
Right.
Or we could go into the Python stuff, that's fine.
Okay, I think Mary is in line. Mary is in line with you. Okay. Okay, then that's fine. At least if you guys join on time, at least you guys will really want to dictate all we should do. Okay, so for Excel, so let's see. I'm sure we already have that our normal Excel file we use in class now. We have the Excel file we use in class.
Yes, I still have mine.
You still have yours, so probably that's what. Okay, let me see. We probably will try and cover some other things. Okay, let's go. Cleaning. Okay, let me look for, or somebody can share it on the, somebody can share on the Zoom or the group. Let me try and look for I don't even know where now is. What I call the file? Workbook, right? Workbook. Okay, I think I've seen mine. Okay, let's quickly go through that. Am I sharing my screen?
Yes, sir.
All right. Good. So usually, the starting point is so we understand the essence of what we are trying to do, right? So here we are trying to build you on all so that you're familiar with most of the data analytic tools that you use in practice. Because most of the tools we cannot cover them in class. Okay. So that's the essence of what we are trying to do at this point. So what we need to know is also not just knowing the tools, but how they are all related. That is how you need all, because if you see the tools are available, right? You see there are so many. So do you have to learn all? The answer is no, right? But again, you need to also understand what's your role as an analyst, right? Basically, you are doing three things, and this is what you must always try to remember. Okay. One, you are trying to what? Extract data. Next thing you are trying to do is to what? Clean and transform. Right? You clean and transform that data. Then you try to what? Analyze. But most times, I usually like preferring to embed this under analysis. But although because you must clean and transform before analyzing your data. Then what next thing you do is to visualize, right? Or you build your report. So this is basically what you are going to be doing as what? Analysis. Can you see that? So the tool we have learned here to extract your data is what? Your SQL, right? To clean and transform the data, you can either use your Excel or you can use your what? Power Query, which is a very powerful tool. Then in analyzing the data, we can use what? Excel. You can use your what? Python. You can use your what? R. Then in terms of building your reports, well, you can also use what? Excel. You can use your Power BI. And you can probably use Tableau. So your choice now depends on the organization. Some organizations still use Excel. Some use Power BI. Some use what? Tableau. But as data analysts, this is where we want ends. Building reports. Okay. So beyond this, so what we are doing right now, beyond this, right? We now move into the area of what they call data science. So what a data scientist will do includes all this, but it goes beyond it. It's now going to start now. One, to build what? Models, machine learning what? Models. Right? And lastly, is going to also what? Deploy that model to deployment. So this is where so this is a bit more advanced than what we are doing here. Okay. So we are starting from this point as data analysts. Okay. So if we see there are so many tools, and all the tools here we are using here is Python at this stage. Okay. So our starting point is to use the easiest one because we see Excel features in almost all the tools said that you must do. Almost all the tasks you must do here, you can use what? Excel. So that's why Excel is still the #1 data analytic tool. I hope that's clear.
Yes, sir.
All right, great.
Yes, sir.
But always remember this flow. Always remember this flow. Your job is to what? Extract, analyze, and what? Visualize. Okay? Because that will always help guide you when you are doing whatever analysis you are doing. So what's my first rule? I need to extract that data. Remember, there's a business problem. From that problem, there's a question. Management wants answers to. Okay? But to provide answers to them, you need data. And where is that data stored? It's stored in the database. So because it's stored in the database, you need to communicate with that database. And how do you communicate with it? Using what? Your SQL. So SQL is the language that you use to communicate with the database to extract the data that you need. But most times you are going to see that data is never clean. It's never ready for analysis. So that's why you need to what? Clean and what? Transform it before you start with the analysis. But in analyzing it, most times putting them in tables, formulas, and all, management, they are not technical people, right? So it makes no sense to them. So your job is now to communicate it in a way that they will understand. So this is where data visualizations now come in. Okay. But it's not enough to put in data visualization, you put in your dashboard. You must also be able to tell a story from it. Because they will they can relate better with the stories. Right? So that's just basically what we have done here. Okay, good. So we can move ahead. And if you have seen that, we say data analytics, there are 4 types of data analytics, right? What has happened, right? You are summarizing what has happened, what's going on in my business. You know? So that's what they call descriptive analytics. What's going on? Why is it going on? That's what they call diagnostic. We have seen sales has been declining. That's what is happening. Why is it going down? So you want to know what diagnose why it's going down. And you can do that by drilling to get the root cause of the problem. So that is why to answer the question of why, you need to break it into what? Various dimensions. So you can to answer this question of why, you need to break it into further questions. Who, what, when, where, and how. Can you see that? So for me to understand why, I need to break them into dimensions. Who is buying? What are they buying? When are they buying? Where are they buying? How are they buying? Can you see that? With that, it will give me some insight on why sales is declining. Who is buying usually relates to who? The customer, isn't it? So I have to go and look for the customer table. What are they buying? It relates to what? What are they buying? What? The product. When are they buying? It relates to what?
Time.
Time. You know, the date or time.
Period.
Yes,
Period.
date or time or period, yes.
Time.
Yes, time. Where are they buying?
Location.
Location, you know, the state, the country, right? Location, geography. How are they buying?
Location.
How are they buying? How are they buying?
Mode of payments.
Yes, mode of payment or sales channel, right? Can be in-store. Yeah.
That's mode of purchase or payment.
Yes. So sales channel, right? Mode of payment, mode of shipment. So that's the how. So once you want to answer the question, you just can even break it into this: who, what, when, where, how. Can you see that? At least this is a basic starting point. Whatever analysis you want to do, just break it into who, what, when, where, how. At least this is enough for what? Basic what analysis. Basic. But you can now start going deeper if you want. So this is why. So that's diagnostic. Now, to know what will likely happen, you see, that's what they call predictive. That's why we are building machine learning models now. To try to what? Explain what is likely going to happen. We are looking at what factors should we look at that is driving our sales. What are those factors we look at that will make customers purchase or not purchase? So that's why we are building machine learning models. So this is where we are currently now. Okay. Then prescriptive. What should we do to make it happen? So now you are now recommending strategies towards management. Since we know this is what's likely going to happen, what do we need to do? Is it not? Either we need to give them discounts, we need to what? Open more branches, right? We need to know when to sell to them or when to send promotions to them. So you now come up with different strategies. Because at the end of the day, hello. Because at the end of the day, what management they are looking for is how does this increase revenue for us? Right? How does it increase revenue? How does it increase profits? Or how is it going to reduce cost? So in all these strategies I recommend, this is what you want to hear. All your analysis must speak to this. Either it's increasing revenue for us, increasing profit for us, or reducing cost. So no matter the grammar we are blowing, you want to hear those three things at least. Either it's increasing revenue, increasing profits, or reducing cost. I hope this is clear.
Yes,
so,
sir.
You see that data analytics, Excel as a data analytic tool, right, can either be used to what? Analyze your past data. So you're looking at historic. So that's where you do your reports and your analytics. So your reporting is just like a summary, those dashboards you do, right? But the analytics itself is just trying to understand the why. They try to understand what the why. Okay. Then if you can also look at it in terms of the future, you now build what they call financial models. Right? Example of a financial model is your budgets. I'm sure we are already in budgeting period already for against next year, right? So some have already prepared their budget against them. So you also what? Budgeting. And in that case, you are also doing some form of what? Forecasting. Okay. So that's why Excel is a very versatile data analytic tool. Okay. And what you are going to see that in every organization, you have your processes, you have your operations. Okay. So we have what they call operating system. So you can have a software that deals with all your operations, like an ERP. Okay. But some of the operating systems may also have form of analytics, right? They may also summarize, but they don't go in depth. So that's why we also need to have what, in addition to the operating system we already have, right? You also need to have what, an analytic system where you can what, have real-time what analytics of what's going on in the business, way deeper than what those custom analytics will do for you. Okay, so that's why you have things like Power BI, your Tableau, even your Excel. Okay, you can use that to what, build your analytic system. Okay, and if you remember how the process starts, it starts with what? Extracting the data, that is getting data from different sources, from different departments, cleaning it and transforming it, bringing them together, right? Creating what, or calculating your KPIs, those KPIs you want to track. Okay, So based on that, once you have summarized them, you now put them in form of report or dashboard or put them on PowerPoint, which you are going to now present to management. And based on that, they now take decisions or what act on those insights. Of all these steps, which is the most important? Of all these 1 to 6, which is the most important? Or where should you as a business focus on? Where should you as a business focus on?
I think step 6, brainstorm and act on insights.
Yes. So brainstorm and that is actually the most important aspect. But where do we spend most time? Where do we spend most time?
Step 2, clean and prepare.
That's step 2, clean and prepare the data.
And prepare the data.
Why is that so? Why is this problem there? Why do you
Because
Most
when you
of
download the
our
data,
data are not stored.
it boils down to what? The data culture. Goes down to what? The data culture. Because most people tend to what? Just keep data, forgetting that any data we keep is going to be used for some form of analysis in the future.
Sure.
Just imagine you are maybe in sales department or you're in finance department. HR, please, we need data. Marketing, we need what data? Operations, we need your data. You will notice that all of them will keep data the way they like, in their own format, in their own structure. So when you want to build the report, it takes you longer time to clean and prepare. So that's why that data culture, that emphasis of data must be driven from the top down. So they can understand the importance of it. Because once you can build that data culture, this now becomes easy for you. This will no longer be a problem. So that's why we always say that anything you learn, you have learned a bit of Excel and you're working with a team, teach them. Because when you say you don't have time to do it, to teach them, you first of all do their work by cleaning and transforming before you even start your own work. And remember, management needs that report to take what decisions. Okay? So it boils down to what? The data what culture. So irrespective of your level, you must always try and what? Build this what? Data culture. If you start with your team first, then gradually as you grow in the organization, you can now start what? Moving it down. Because you see now, almost all businesses now, they are going towards AI. Right? They are moving towards AI. Because everything now should be what? Automated. Apart from being automated, also what? Enable you to what? Make decisions on time. So with AI, it tends to what? Improve what? Productivity, 10x, 50x, 100x. So what would have required 10, 20 people to do, only 2 people may be required to just do it. Because the AI itself is not going to replace anybody. It's the people who use the AI that will replace their job. Okay? Which means for an organization to now be AI ready, it means this AI requires what? Data. Can you see that? As long as you still have problem here at this point, this will always be an issue when you want to start implementing. Because it's garbage in, garbage out. The quality of what decision you take is a function of the quality of what information or data that you have. Okay? So it still boils down to what? Data culture. I hope that is clear.
Yes, sir.
Yes, sir.
All right, great. Then in terms of the framework, so if you look at Excel, you can use Excel for different kind of things, right? To collect data, analysis, automation, optimization, reporting, collaborating from different departments, different units, right? storing different kinds of data and transforming that data, okay? So you can use it for anything. So first of all, you need to identify the problem, know what appropriate tool to use, know how to present the report, and also how to automate it. Okay, so that's just basically what you use Excel for. And in terms of data entry, I'm sure this part you're already clear with all these parts. Working with data sheets, are we clear with all these ones? Entering data in Excel, I'm sure we are familiar with it, right? Avoid putting spaces there, right? Avoid spacing. Is it not? Avoid
Yes.
spacing. Don't go and put currency sign when you are typing. Right? What again do you mention in this entering data in Excel as important? What other thing again you mention as important when entering data in Excel? Now understand the data type. You see, understanding your data type when I
Don't hide.
Is it not? Understanding the data type, when it's on the left, when it's on the right, because it has implications. Okay? We know how to fill down. Do we know how to fill down? I'm sure we know how to drag. We know how to double click. Do we know how to do this at least? Hello?
Yes, sir. We know.
Okay, all this. If you don't know, speak.
Yes, we do.
All right.
We do.
Good. So another aspect we have always emphasized is how you keep your data, isn't it? Remember
Yes.
those 7 rules. You know, no empty rows, no empty columns, 1 row of header, no total or subtotal, isn't it? All data should be on a single column. All variables or categories should be on a single column. No obstruction around data. Okay. Some other things we talked about is in terms of avoid merging. Avoid merging cells, rather repeat them, isn't it? And that says avoid hiding. Whether rows, columns, avoid hiding. Then the most important data should come first, which is usually your primary key. And your primary key is a unique identifier. Okay. We also mentioned that instead of you putting your full names this way, rather separate them, surname, first name, right? Instead of you writing, abbreviating name, female, it's better to put so that we'll be sure what you are saying. Okay. Then dates, your date, when you're putting your dates, rather follow this format. Year, month, date format. Year, month, date format. Because globally, we read it the same way. Because if I have 3/5/2023, somebody in Nigeria will read it as what? 3rd of what? May, is it not? Imagine this transaction was 10 million. But someone in the US will read this date as what? Someone will read this date as what in the US?
23rd of May 2003.
In the US, is that
No,
No, this is 3rd of May 2023.
it is what?
yeah.
They read it as 5th of March.
5th of what? March 2023. So a transaction of May, you are reading it in March. So most times to avoid that kind of problem, we rather put it in this what? Year, month, date formats. Okay? Globally, in almost all databases, that is how it works. Is that clear?
Yeah.
Remember again, when entering things like phone number, account number that start with 0, always put your words, single quotation mark, then this thing will stay there. All right, so that was working with Excel sheet. I'm sure we are familiar with this already.
Sorry, we didn't get the phone number, sir.
Okay, I said you should put the single quotation mark, then you can enter your phone number.
Okay.
Can you see that?
Single quotation mark.
Yes, single quotation mark. You know you have double quotation mark.
Yes, yes.
Single quotation mark.
At the beginning, then close it.
Yes. No, you have to just try it. That's all.
Okay.
Just one single quotation mark. One. That's all.
Okay. Okay.
Or you go and format yourself. Okay. Then we also talk about how you highlight your data, isn't it? If I want to highlight the entire table, Control A. But if I want to just select only the table, for example, only the data maybe from here, Control Shift, right arrow, down arrow. Same thing, Control Shift, right arrow, down arrow. Okay. If I want to select, I just hold my Shift button. I don't want everything. I just only want this. I hold my Shift button. Can you see that? I hold my Shift button. So that's about working with Excel sheets. Right? And this is why the table layer, should we keep data like this? Does it make sense putting your data like this?
No.
So rather,
No.
what we do, we should rather put it in a structure like this. Can you see that?
Yes.
Yeah.
So we now know this is the data ready for what? Analysis. Now this is beyond spelling errors. Right? There can be spelling errors, there can be white spaces. Well, those ones you cannot avoid them. Okay. But in terms of how the table structure should look like, this is what your table structure should look like. So, as much as possible, as you are improving your analytics skills, right? Also try and check, how do we keep data in our organization? You see some people keep it like this. Maybe somebody who have been maybe the head of IT or analytics, he learns all these things maybe in the 90s and he's already an elderly person. So he has been doing things the way he learned it then. It's not that you have learned or they have learned something before you, doesn't mean they know it better than you. Okay? So gradually you start trying to see how you can also change those things. Okay? Some people they just say that's how we do it and that's how it is, but you also need to understand that it's just to make life a little bit easier for you. Otherwise, you start struggling every time to first transform before what analyzing. All right, I hope that is clear.
Yes, sir.
Great.
Yes, sir.
Great. Removing blank rows. I'm sure we are clear with removing blank rows. So remember, if I want to select, I want to remove my columns, what do? I can right click and delete. Same thing, I can press Ctrl minus and it's gone. Ctrl minus. So it means if I have 3 empty columns, I want to take one after the other. I will have to click the first one, hold my Ctrl button, click the second one, and click the third one. Guys, I've selected individual columns. Then I'll press Ctrl minus and it's gone. Ctrl minus. If I want to add column, it's Ctrl Shift plus. Can you see that? Ctrl Shift plus to add columns, Ctrl minus to delete what the columns. Okay, I'll do it one more time. I'll click on this, hold your Ctrl button, hold your Ctrl button, hold your Ctrl button, and Ctrl minus. That's all. But if I have a group of columns here, what I can do in this case, I click the first one, the first column, hold my Shift button, but I want to select a group. If I was going individual, I'll hold Control button. But if I want to select as a group, I'll hold my Control button, my Shift button now, and click the. So I'll click my first column, hold my Shift button, and click the last column. Guys, that is select as a group. Control minus and it's gone. Is that clear? Are we clear with that?
Yes, sir. We are.
Yes, yes, sir.
Great. So same thing you can do with your columns, your rows. I'll click on this, hold my Control button, click on this. You see that I can easily press Control minus and they are gone. However, we can, because the rows are so many, right? So it will be a little bit difficult and time consuming. For your columns, preferably do it manually. Just delete it manually, okay? So if I want to select all the rows automatically, So what I can do, I'll click on my first column, hold my shift button, click on my last column so that I can select the range where I want. So what I'm going to do next, I want to select the blank rows. So how do I do that? I'll press Ctrl G, go to special. Can you see that? Ctrl G is for go to. So go to what? Special. Then I'll click blanks. Can you see that? Go to special, then blanks, and I click OK. Then to select it out for me. Then I'll press Ctrl minus entire row, and I'm good. We are done. And my data is ready for analysis. I'll do it one more time. So I'll click on the first column, hold my shift button, click on the last column. Are we there?
Yeah.
On the last column. So what do I do next? Press Ctrl G.
G.
Ctrl G. G for go. Special. Blanks and click OK. Once you select that, Ctrl minus. And if you don't do this Ctrl minus, then just come in and press delete. Can you see that? And it's gone. So that's about blank rules. I'm sure that is clear.
Yes.
We're clear with this rule. So let's move to the next one. So here is when you're working with large data sets, right? Large data sets. And you see, when you're navigating, you want a situation where you can always see the data. So when you're navigating, you should always be able to see it. Okay. So in that case, what do you do? So if I want to always see my row header and my column header, then I'll just come at this point, click on my view, come to free space and click on free space. Now I can easily navigate it while my headers will always show. I hope that's clear.
Again, sir,
Yes,
please.
sir.
Yeah,
Take it again, sir.
take it again. Okay,
Yes.
so let me first remove it first. So what do I do? You see my heading here. This is
Yes,
my
sir.
right? So I want always to see, so I click here so that I always see this column. And I want to always see this row. Can you see that?
Yes, sir.
So I'm clicking at this point. Okay, then what do I do next? I'll click on View tab, then come here to my free space and click on free space. And I'm good. Can you see that now? And I am good. Sorry, I took for granted that we already understand the difference between rows and columns, right?
Yes, sir.
Rows are identified by numbers, isn't it? Your columns are identified by what? Alphabet.
Alphabets.
And where the rows and columns meet is called a cell, is it not? And this is called the cell address. Can we see that?
Yes, sir.
And remember some other things, always label your sheets. Always label your worksheets. And we say as analysts, when we're analyzing data, we try to work at least with 3 sheets. What are the 3 sheets? Your data sheets. What other sheets again? Your analysis sheet and your what? Report sheet. But if you have more analysis you want to do, you can also create more other analysis, right? But that report summarizes it. Or alternatively, you may want to have several other reports, then the dashboard is a summary of all your reports. But if it's just only one report, that report sits as a dashboard. But if you have series of reports, then that one-page summary of all those reports is what we refer to as what? The dashboard. Okay, so always try to what? Label your worksheets. And remember, for the data sheet, you gave those 7 rules. 1 row of header, no empty rows, no empty columns, isn't it? No total or subtotal, right? All dates on a single column, all variables or categories on a single column, no obstruction around what? The data. So those rules we gave in terms of how your table should look like relates to what the table. Can you see that this relates to what the data? This is how your data should look like, your data sheet. This is exactly what it should look like. Okay, it is based on this they will now start the analysis and building of the reports. So sometimes when you are trying to also present, when you are doing your analysis and you extract out the data, because the data in their natural form don't make any sense. So sometimes when we present the tables, we also want to highlight certain features in the tables. For example, we want to highlight where have been our highest revenues, right? Our highest revenue. So I'll highlight it. So how do we highlight it? Control Shift, right arrow, down arrow. Isn't it?
Yes.
Good. Then what do we do next? We want to highlight certain things. So for example, I'm looking at which revenue is above about 4.5 million. Then I'll come here, greater than or equals to 4.5, 1, 2, 3. Now I've highlighted it, so I want to make it green. Can you see that? So just quickly what highlights certain things for you. So that's the same way it applies to every other thing. So you want to get less than between duplicates. So for example, do I have, so I come here and highlight, I'm looking for duplicates. Duplicates, can you see that? It says there's no duplicates, but do you see any duplicate there? Can you see any duplicates name there? Can you see any duplicates name there?
Yes, sir.
Which
Yes,
name,
there is.
which name?
Clear Gutes.
Claire.
Clear.
Why is Excel saying, I don't know what they are talking about, there's no, but they are all different people.
Because of the space between.
Because of the spacing, can you see why spacing is very dangerous? So I have to remove the space, put one space there. You know, I have another one. If I check again, can you see another space again?
Yeah.
So why spacing is very dangerous. Okay. So when there's space, I cannot find the duplicates. Okay. I can't find what duplicate. So that's the same way you can just check duplicate values so I can see their duplicate values. Okay, good. Other things again you can do with your conditional formatting is to check the top 10 items. So just the way you have top 10. We'll just bring out, highlight the top 10 for you. Same thing you can do bottom 10. Can you see that? And that thing again you can do above average. You see anything above the average, anything below the average. So once you have anything above the average, again, if you want to do any scale, color scaling, you can come here, your data bars, these are data bars, just to highlight it. So just for example, I have store here, and I highlight it here. I just want to put the word data bars. I can put the data bar there. So just at a glance, we can actually see what's going on. Can you see that? Or anytime you want to clear your this thing, you come here, clear from entire sheet, and you're done. And that thing again we can do is to use our color scales. Can you see that color scales? They are always in pairs of 2. So for example, if this was revenue, since this is revenue, I want to maximize revenue. So I'll use the first one. So anything above the average, give it green. Anything below the average, give it what? Red. Anything within the average, give it amber color or yellow. Okay? But if it was cost, our objective is to what? Minimize cost. So anything below the cost, average cost, below it, give it green. Anything above our average cost is a problem for us in business, isn't it? Because we want to minimize cost, not to maximize cost. So that already tells you that is high cost, so we give it red. So that's how they're always in pairs of 2s, in pairs of 2. Okay? In pairs of 2. Then you can use your what icon set also. Use your icon sets. So that's pretty much about that. I hope that is clear.
Yes, sir.
In case anything is not clear, you let us know. Because this is because we have done them in the past already, isn't it? So that's why I'm just trying to rush so that we can get to where we need to start from. But if anything that's not clear, please feel free to ask. I hope that's fine. Okay.
Yes, sir.
Okay, good. So for sorting, normally what we normally do with sorting, you try to highlight your entire data, right? What do we do next? I come here to sort and filter, custom sort. Then probably here sort by state. Can you see that? Sort by state, and I click OK, and to sort it by state. But what we also notice in the columns that they are not arranged properly, isn't it? So what do we need? We also need to sort that. And all softwares, whether Python, R, SQL, whatever tool, by default, it sorts from top to bottom. But here we are trying to sort from left to right. Okay, so if I want to sort it out, same thing, sort and filter, custom, then I'll come here to what? Options. Can I see options? Then I'll switch it to what? Left to right and click what? OK. And because my state starts from row 2, where I have my date start from row 2, I'll say sort by what? Row 2, and I'll click OK. And that's how it will sort it out for us. Clear?
No, sir.
Can
Can we take it again, please?
I'll take it again, sir. The first one, you get the first copy. I will highlight the entire data. On no account, you just highlight state and say you want to sort by state. You go and embarrass yourself to imagine you are carrying Imo State to Lagos, taking Lagos to Kaduna. You see that I am going to do presentation to a board or to management. So those little things that can cause embarrassment, avoid it. So what do you do? Highlight the entire data, just in case the enemies want to be at work. You come here, sort and filter, custom sort. Have you done that?
Yes, sir.
Then from there, sort by what? I want to sort by state. Can you see that? Sort by state. And I'll click OK. If you're using the older version, it may show you sort by column. Column A, column B, column C, column whatever. Then you can now choose the column that you are sorting by.
Okay.
All right. So that's for the states. I'm sure
States.
it's clear. Have you got the states now?
Yes, we got it, sir.
Yes, sir.
Good. So now for the dates, what do? I will highlight these dates. When I highlight these dates, all right, when I highlight these dates, what do I do next? You can either just click sort and filter, or you can just right click and you can see sort. Can you see sort?
Okay.
Yes.
Okay. Now we are not sorting, we want to sort by row. Can you see that? But now we are sorting by column. So what do? We come here to options. We now switch it from what? Left to
That's right.
Right.
click OK. So now it has switched to rows. So I now say sort by what? Sort by row 2. And I will click OK. Now and that's it. Clear?
Yes, sir.
Great. Now, another thing again we can do, most time we want to filter our data. Now, even your cost, even when you are sorting, right, you can also sort by color. Can you see that you can also sort by color? You can also sort by color. But let me first show you how to put the filter button first. So whenever you want to filter, the same way, just come here, sort by filter. Sort and filter, you can see filter there. Okay, that's the filter. Now, what's the difference between sorting and filtering? You know, in your sorting simply means arrange in a particular order, either in ascending or descending. That's why when you want to do your analysis, top 5, bottom 5. Bottom 5 means in ascending order, right? But top 5 means in descending order from highest to lowest. But bottom 5 means from lowest to highest. Can you see that? From lowest to highest. Top 5 means from highest to lowest. That's in descending order. That's sorting. But filtering means extract the data based on a particular what criteria. Based on a particular what criteria. Okay? Based on a particular what criteria. You finished squeezing orange juice, isn't it? Because when you are squeezing the orange juice, it comes with this shaft. But you only want the juice, is it not? What do you put? You put like a seed there, is it not? I want only the juice. You know, that's your criteria. Then you now put it. What does it do? It filters it. Okay, so that is filtering. So how do we filter? We come here, sort and filter. Can you see filter? So I'll put the filter button there. Sort and filter. Can you see filter? If I want to remove it, I'll remove it there.
Okay.
Or I'll press Ctrl Shift L. Ctrl Shift L. Ctrl Shift L. If I have this data now, I can come here again, Ctrl Shift L. Can you see that? Ctrl Shift L. Ctrl Shift L. So that's to put the filter button. And you see, when I click down on the filter button, you can see sort by color. Can you see I can also sort by color? If you bring that particular color. If I say no fill, that means bring all you want without color on top. So I can also sort by what color. Sort by color. Even for example, even if I have a font color, maybe I don't have font color, all right? I can also come here, the same thing. I can say filter by color. Can I see font color? Now say red. Now bring only the red color for me. Can you see that? So filter by green to only bring the green for me. Can you see that? So that's where your filtering now comes in. So I can clear that. So clear that. All right. So the same way, if I press Ctrl Shift L, I want to bring only meter. Only meter. Then I will click on that and click only meter. So click meter. Okay, good. So that's how to work filter. I hope this is clear. Filtering. Are we clear with this? To filter. And take note, when you filter, you have to extract it. Never copy and paste on the same sheet. Because the moment you filter your button, you will notice that some of the rows are hidden. So I can, even when I paste the data, it will not see everything for me. So what do? I will always have to paste on what? New sheet. Take it to a new sheet and paste it so that it will get out my filtered data. Are we clear with sorting and filtering now?
Yes,
Yes,
I am,
sir.
sir.
All right, good. Text to column. So these are okay. Let me, before I go to text to column, let me just quickly explain. You see that your table layout. Let me show you your table layout. You see your table layout now, right? You see, once you have cleaned up the data and it's ready for analysis, now Excel now embeds some certain AI features in it. Now, if you notice, for those of you who are looking at 365, do you see there's a tool called Analyze Data? Can you see Analyze Data?
Yes.
Good. Now, it means first of all,
Sorry, sir, what version is this?
365.
Okay.
How do you know your version? So if I click on my file, click on my account, you will see Office 365.
Okay, sir.
Office 365. Now, for some of us, you know, there's now Python in Excel, right? You know, there's Python in Excel now, right? So if you come here to this your account, you can see Microsoft Office 365 Insider. Can you see Insider? So you can ask to change channel, change to a beta version. So you change to beta version. Then agree with the terms, click OK. Can you choose version? This is your current version. Switch on to what beta channel. So Python is in this beta channel. You know, when I say beta, it's still in trial. So that's where actually you are going to change it. To change to beta channel and click on OK. So you are expected to have a mail. Then again, also try to update. Update in case there are any new updates. Just click on what updates. No, don't check one. So I don't understand. But once you check, I hope you will not go and tell me that, oh, enemy, so okay. So that's it for that. So you just try and switch on to better channel. So how do you know it's there? If I come to my formulas, can you see Python now? Insert Python. Can you see Python in Excel? Yes. Python in Excel. So if I type equals to py, can you see that? That's our Python. Can you see that? So the same way we have been doing it in your Python, the same way we just say import pandas as pd, import, can you see that? It works exactly the same way. Import numpy as np. Can you see that? So it makes life very easy for you. Okay. Same thing if I highlight the entire data. So for example, if I come here equals to py, so py is the Python, right? So if I highlight the entire sheet, the entire data, you notice that it saves it in Excel, right? So I can put df is equals to, so that was a data frame. Can you see that? It has switched it to what? A data frame. The answer, I don't know. A data frame. So when you are running it, remember I control enter the same way you do it. Control. You see the data frame. So if I want to see the data, what do I do? I'll just click on it. Can I see the data now? So just the same way we have it in Anaconda, that's how you have it here. So that's your Python in Excel. So
This
same way,
Dr. Koye.
yes.
Sorry, excuse me, please. Good afternoon. Please, I use Office 365, but I don't seem to have the Python linked to my Excel. What do I do?
That's what I showed you just now. If you go to file, go to your
Yeah.
account. Do you see anything like Office 365 inside there?
Yes.
So click on it now. Can you see change channel?
Change channel. No.
But
No,
you have Office 365 inside there.
yes, I do.
So you don't have anything like change channel like this. But another thing
No.
again, make sure you are signed in. Are you signed in to your account?
Okay, maybe I'm not signed in. Okay.
Yeah.
I am signed in actually because I can still
You can
sign
sign
out.
in. Check now. See change channel. Your channel will be the basic one. So you now change it from this basic to beta type channel.
Ah, okay.
Then you agree with all the terms and conditions and click OK. Then probably update and you update everything. But it may not come immediately. It may take you like some days, a week, and so before they will.
Oh, I see, Dr. K. It seems like I have to sign up for some access. Join Microsoft 365 Insider, right?
Just follow the instruction. Just follow the instruction.
Okay. All right. Thank you. Thanks a lot.
Just follow the instruction. All right. So what I'm just trying to show is that once our data is clean, you see the analysis becomes very easy. So on my home tab, you see, can you see analyze data? Can you see analyze data? On my home tab, can you see analyze data?
Yes, sir.
Just click analyze data, leave it. If you go through your data and analyze it for you, that was all. Then you can even ask questions. What questions do you want to ask from this data? What questions do you want to ask from this data? What questions do you want to ask this data? That's why, because of AI, there's now a new skill everybody must start learning, what is called prompt engineering. Prompts. You now have to prompt the AI, because if you learn to speak his language, you learn how to structure it, right? It will give you that result. But if you put it generally that is too broad, it may not really give you that result. Okay. So for example, what question do you want to ask this data now? What question do you want to ask this data? Hello? Let's say hi, let's say best salesperson. Let me see. Best salesperson. How many? You see that by the time you start asking and it doesn't understand, you say, who is the let's say highest. We can't find good answer. Can I see that? So I mean, so I have to start learning how to what ask it the question. So I say, okay, sales person by what now? Sales amount. Of my Excel, just hold on, comes first. Sales person by sale amount. So we can't find good answer. So let's see insight one. So which one is one? Have I labeled my table? My table is labeled. I hope I don't have missing data. But your table must be clean. Once it's clean, it becomes easier for you. Let me see another. Let me look for another table again. Where is that other one? Aha, this one. So let me see this one. To convert the table control P, let me call it scale. Okay, scale already exists. Let's call it so I'll come to my home tab. Let me try and analyze data. You're analyzing. So can you see that? So it has done all the analysis for you. So it shows 30 results. So it has done up to 30. You check the one that you want.
Wow.
Can you see that? Then let me see. Which sales channel is the highest profit? Can you see that? Does answer me?
So install.
Yes, install. Yeah. So this one new skill now that's now trending is called prompt engineering. Because now with AI, you need to be communicating with the AI. You need to be communicating with the AI now. So that's what they call the prompt, and you need to prompt it. Okay, so the better your prompts, the better the results or the output is going to give to you. All right, guys, I hope this is fine. Chinoye, can we switch? We have other people ready now.
Yes, sir.
All right, guys.
Thank you, sir.
Thank you.
All right, so probably from next.
Thank you, sir.
Yeah, so from next.
Thank you, sir.
Yeah, so next week we can continue from here. That's why even if I have taught this in the past, anytime I teach it again, there's always something I always add for you guys. So even if you are used to it, anytime I teach anything again, there must always be something new you always learn. Okay? Because with Excel, you can never say you have finished learning Excel. In a lifetime, you can never finish learning Excel. Okay? There's always something new in Excel. All right, guys, so let me switch to So, okay. All right. Okay. Okay, how can I see my Excel screen? Can we see my Excel screen?
Not your Excel screen.
Sorry, my Jupyter notebook.
Yes, we can see it.
Okay, that's All right. So what we are going to be doing today, so we have looked at basically two machine learning algorithms. We have seen the regression, is that not? We have seen what classification, right? Under regression, we looked at what the linear regression. Under classification, we have looked at what logistic regression. Okay. Or probably maybe let me talk about this again, because there's something I want us to do. Because you notice that as at this stage, we just assume the data is clean, right? We assume the data is clean. We assume that the data is clean, but most times your data is never what clean. Okay, you need to always what clean and what transform that data. You must always clean and transform what data. All right, you must always clean and transform that what data. So if we want to run a machine learning model, right? So if we quickly remember how we do that. So let me, which data did we use last time? Which data did I use last time? Which one did I use that last? Which data did I use
Last week it was advertising.
Advertising. Okay, let me look for the copy as part advertising. Advertising. Okay. All right, good. So if I want to bring in my data, so the first thing I need to do is import my libraries, right? So import what? Pandas as ED. Import NumPy as NP, isn't it? What other library means? Are we visualizing anything? Okay, I'm not visualizing for now. Let me not visualize it. So the next thing I need to do is to bring in my data, isn't it? So how do we bring in our data? So you see what we did in Excel. Guys, see that's the way I wrote it in Excel. That's the same what you are doing here. But you are now Excel and give you opportunity to type your Python codes right inside Excel. So which means I can build my machine learning model inside Excel. Okay. But the way Excel will bring out the result, if you are not familiar with it here, it wouldn't make so much sense to you there. Okay. So to bring in my data, what I can simply do is to, so normally what we would have done is to have df is equal to what pd dot what read what is it CSV file, right? Read this.
Yes, sir.
I can do it this way and say df. Can I see that? You notice that in Excel, when I did, it just showed me one small box, but this was the result we were seeing. This was the result we were seeing there. This is the result we were seeing there. Sometimes again, you notice that some people, instead of them doing it this way, what they would have done, they would have just said path, they'll create a path like this. They'll create a path like this. Can you see this now? Instead of me right here, I now say df is equal to what? pd dot read what? CSV, then I'll put the path there. Can you see that? Which one is easier for you? Or which one is cleaner? Which one looks cleaner?
The one
So
with
please,
path.
Dr. Koye, please, how did you get the file path?
Okay, you know on your desktop, you know when you right click on your desktop, you see copy as path. When you copy on your desktop, you see the file, just right click on that file, you see copy as path on your desktop. Or where the location of the file is, just right click on and say copy as path. Copy as path. You get that? Copy as path.
No, I'm sorry, I didn't get that.
Oh, you didn't get that.
Do I go to the file? I go to the file and right click on it.
Let me try and show you how to do that. Okay. Oh, this one does not allow share entire screen. So let me go from my. So this is my desktop, right?
Yes.
This is the file. Can you see when I right click on it?
Yes.
You see copy as path.
Yes, I can see yours, but I can't see that on mine.
Okay, if you don't see it on yours, because this Windows 11, right? So what if you hold your shift button and right click? Hold your shift button and right click. You have copy as path now.
My shit. Okay.
Hold your shift button and right click. You have it as copy as path now.
No, I can only see copy link.
Can you share your screen? Let me see.
No, because I'm not signed on. I'm using my laptop. I'm signed on my phone. Let me try and I'll let you know when I'm ready. I will
Just once you
log
just
up.
which Windows are you using? What version of Windows are you using?
Do I know what version? No, I don't know what version.
So when you right click on the file, you don't say it, you do see copy.
I can only see copy when I right click. I can see copy link. That's the copy and then copy link.
By the way, where are you looking at? Is it on your desktop? Because if it's on your desktop, you're not going to send a copy link. So where are you seeing the file you're talking about? Where is file?
It's in my OneDrive.
No, now that's one.
Is that why?
OneDrive is online now. Download it now.
Okay. Oh, I see. Okay, all right, that's fine. Thank you. That's
Put it
okay.
on your desktop.
Okay, all right. Thank you.
Even that your OneDrive, even if you copy that link, right?
Yes.
You should also be able to read it from it. You should always supposed to also be able to read it from it. But that just save it on your desktop. Save that file on your desktop.
All right. Thank you. Thank you.
Like easy for yourself. Okay, good.
Okay.
Okay. So we have that part. So if you remember that for when you are working, you need to first of all break your model into two. You know, remember it is y as a function of what? X. You know, so which means I will need to get my what? Y variable, right? And what's my y? What's my y here? What's my y? What's my y in this case? Yes, what's my y?
Those that clicked on the ad.
Yeah, those that click on the ad, isn't it? So those that click on the ads. Good. So y is what? Click ads, isn't it? Y is what? Click towards ads. So sometimes when you look at the data, you must be clear. Which is my target variable? You know, you must be clear which is your target what variable. So it is based on your target variable, you are now going to what select. You know, you are now going to what select. Where's my so you are now going to select. So what I can do here, I can say df.column. So I'll get the exact names. Right? df.column. So you just bring out all my columns. Then because it's this, I will just copy it so that I will not have any problem and paste. So then I can move that so I can copy it and paste. Just make sure that it opens and closes, right? So if I now have y, so this is my y. My y, okay? Y for my x, what's my x? What's my x? What will be my x? Yes, what will be my x?
last week we said that X was the time that was spent on this site.
You pick out all the column results. Now you see, notice that if you look at the data, when you are running regression, you cannot use text like this to run regression. You will need them as what? Numbers, quantitative data. So if you were text like this, you don't have to go and convert them. So much later we'll try and look at how to do the transformation. Okay. So you now have to convert it. So what we are working with, we are working with only the ones that have what? Quantitative data. Can you see that? So for example, time spent, age, area income, daily internet usage, maybe mail, then click on ads. Can you see that? So those are the columns I want to use. So because of that, I will just select except what? Even timestamp I don't. So I'll select up to mail. Right? I'll select it up to mail and come here and say GF. And let me run that. However, when I run X like this, can you see that? Can you see add topic line and city? They are still text, so I don't need them. So I will delete it from here. You see that? Then I'll run it. So this is now my word X. So you see, when you are running it, they must all be in what? Quantitative form. Okay. If you have cleaned your data, let's say you have cleaned your data. Let's assume, for example, mail was our target variable, while all these other ones are our what? Features, right? So what you can also do, you have said X is equals to what? X dot drop. What am I dropping? Which one am I dropping from here? I'm dropping mail, isn't it? Mail, then add is because it's on the column, add is equal to 1. So in that case, I have dropped it. So I would have used this method. This would have just been straightforward for me. Okay. But because here we also have some other variables that we don't need. So that's why we have to first select the columns out. Then we now drop them. Okay. Or I would have just put here drop. So another way I would have done it is just to say drop. Then I will use open bracket and say put the columns I don't need. Then I will now run it. So that's another way of doing it. But the most important thing that you have what? The variables you are working with. So let me quickly import it again. So for my X, this is my Y, and this is my what? X. So I would have used any of the methods. Okay. So just to be sure that this my data is complete. Okay, good. So we have this data. So what's the next thing that we'll do? What's the next thing that we'll do? What's the next thing that we'll do? You know, before this, I think we have cleaned the data. So we're not talking cleaning now. After this, I will explain how to clean. So what's the next thing that we need to do? So once we have built our model, what's the next thing we do? After you have built your model, what's the next thing that you do? What's the next thing I will do? Once you have built the model, what's the next thing that you do? What is this? What is this? After building the model, we have specified our targets. We have specified our features. Remember, before this stage, you must have what? Clean and transform your data. Okay? Just because we are trying to explain the concept, so that's why we are not really going into data cleaning. Yes, you what? Train and test. So that means you have to split your data. You split it. What are you splitting into? Into what? The train data and train into what? The test data. Okay. So we need to what? Split it. So how do we split the data? we'll come here and say what? From which library are we using now? I think from sklearn dot what? Model selection. We import what? Train test. If you want to avoid this, at the beginning of when you're importing all your libraries, you have brought all the libraries you require here. Okay? But if not, then you can go using this method. All right, so what do? We need to split them into what? X train. What again? X test, right? Y train, and what? Y test. So we want to train test into train, test, train, test, So am I training and testing? Use your X, what Y. For example, because I always don't remember, if I press the tab, it will not bring it. Can you see that? Train test, it will not use test size, so you can now see how it looks. Can you see that? So this is how you actually will learn it on your own. So you can now copy this one out and go and do that. Okay? If you are learning it. So I'll open that. So what's it I have there? So X, Y, comma, what's my text size? Text size. What text size are we using? What text size are we using? Remember we said test into train and split into 80-20, 70-30, 25-75. So which one should we use?
80-20.
Okay, 80-20. Okay, 80-20. So what will I do there?
0.2.
So I'll have here 0.2. Okay. Random states. You want to use random state, whatever you want to put there, put there. So I'll have all my X trains. I can now see that I've now split my data. Can you see that I've now split it? So the thing here is that on the train side, this is what the model is going to see. The model will see this one. The model will use to see this. So this training simply means you want to write exam. You want to write exam. It's not. Exam is going to be like the test. It's not. But for you to read this, to prepare for this test, you must have something that will guide you, not. So you go and read, not. So that you're reading is what you are doing, you are training. So it means maybe I'm giving you like past questions. Go and prepare. Is it not? So you are giving it past data to go and learn. Once it has learned, what do you now do? You now give him a test to now try. Before you now take it to the real world, that's where you now deploy. But you need to now know, depends on his accuracy, is it not? The higher the accuracy was, the better. So I hope you are clear with the concept of train and test now. So we need to go and what? Train him, is it not? Train him. But because they are of different sizes, you notice that some will have 1,000, some will have, so you need to bring them in the same level. So that we call what? Scaling. We need to bring them to the same what level. So we call that what? Feature scaling. Okay? You have to what? Scale it. So in that case, we can have from what? sklearn dot processing pre-processing import standard scalar. I hope that's good. So once I have brought that, so what we can now do, we can have standard scalar, maybe for my X. So I'll just create initiate, they call it initiate the instance, just let it run. Standard scalar. So anytime instead of me, I have done this every time to run, but it's easier to just work with this as the alias. Okay. So I can just create that standard scalar there. So anytime I want to standardize, I'll just use this standard scalar there. Okay. So whatever I do to my train, I will do to my test. So I have X train. What do I want to do? I want to standardize it. So standard scaling over X dot what? Fit transform. So I want to transform it. What am I transforming? My what? What am I transforming? The X now, right? Is that what I'm transforming? Is it X I am transforming? What am I transforming? Which data do I want to transform?
Yeah, X.
Is it X? X means, look at X means the entire data, the entire features. But remember, we have broken the data into two parts, the train and test. Can you see that? So what I am transforming is what? The X train. Do you see that? I'll do it for what? X train, and I want to put it back in the X train. You see, this is the X train data. This is the initial one, X train. Let me do it here. So you can see the data. Can you see the X train data? So when we finish running it, so that we can see what it will transform into. So this is the X train. So let's transform this now. Now let me run X train now again. So you see. Let me transform it to X train. Can you see difference? Now it has brought them to what? A standard scale. Can you see they are all in the same level now? They are not so far apart anymore. So this is called what? Feature scaling. You have brought them down to the same what level. Whatever you do to the train, you must do to the test. Whatever you do to the train, you must do to what? The test. So X test will now change here to what? X test. And see that. So if I change here to what? X test. So you see that brought it down to the same level. So whatever you do to one, you must do to the other one. So I hope this is clear. So now we have transformed it. What's the next thing we are going to do? We are now going to what? Run the regression, But which model, which algorithm are we going to apply in this model? Which algorithm will fit this model? Which algorithm will be appropriate for this? Which algorithm will be appropriate for this? Which algorithm will be appropriate for it? Yes? Which algorithm is most appropriate for it?
Is it logistic regression?
Logistic. Why logistic? Why do you say logistic?
Because there are several X variables.
So remember your choice. So if you remember your Y as a sorry, if I say just join us today. Sorry, this is the horror part.
Okay.
This is the horror part. So just watch with care.
All right.
Watch with care. But all you get to this level very soon.
All right. Thank you.
You'll get to this level very soon. But what I just need to do, even forget about the coding that we are doing, just try to see all those machine learning. When they say they are building machine learning, this is how it happens at the back end. It's just like you are seeing a Coke and Fanta, you are just seeing that fine bottle with the contents. But before that content has come out, or before you bake a cake, there are so many things that goes at the back end, is it not? You are seeing the beauty of it. You are seeing the application of it, right? Such as recommendation system, prediction, whether it's going to help you take decisions. Those are the outcome of it. But what's happening at the back end? This is what's going on there at the back end. It's like you are going to the kitchen. Before your wife will prepare the pot of soup, is it not? You are seeing the pounded yam, but you know the process at the back end. That's where we are. You know it's hot. During when you are cooking it and it's hot with pepper, spice, onions entering your eyes. That's what is going on here. Okay. It's when we now finish, then you now see the predictions that's going on, but this is just at the back end. All right. So most of the models you are going to choose depends on what? Your target variable. Remember, if your target is continuous, we are going to use what? Linear regression. You know? But if your target is what? Binary, we use what? Logistic regression. Can you see that? Logistic regression. So that's the classification. So this is classification. This is what? Linear regression. Exactly. So our choice of logistic regression is because our target variable has what? Only two possible outcomes. Either they click or they don't click. Can you see that? But where it now has more than one, more than two, that means it can be maybe their choice. Maybe the particular choice, there's an order to it or there's no order. If there's no order, it's called what? Multinomial. Multinomial logistic regression. That means no order. But if there's an order, that now becomes what? Ordinal logistic regression. Can you see that? So there are different levels of logistic regression. So in this case, we are using what? The binary logistic regression. So the choice of the algorithm we are going to use is a function of the targets. But this is for classification case. Remember for supervised machine learning, there's always a target label. The target is labeled. Okay. But if it's unsupervised, that means there's no target label. So that's why you have different what conditions. I hope that is clear. Are we clear with this?
Yes, sir.
Okay, good. So let's quickly go to. Well, I want to quickly enter. But we have done this last week. I just want to just do a quick refresher. So next thing we are going to do is to what? Run it using what? Logistic regression. Now I know that it's logistic regression because of what? I know the condition. That's why when you are going into data science, beyond this application, you also need to have some idea of what's going on at the back end, the conditions to use them. Because most of them have already been done in the package, so it's easy for us to implement. But many people, you see, they implement without even understanding why they are choosing it. They say, oh, it's 1 and 0, because 1 and 0, but you need to know why. So that's why it's also good to understand what the theoretical what framework that guides it. So you understand it much better. All right, so since it's logistic regression, I'll take from what? sklearn dot what? Linear what? Model. Import what? Logistic regression. Okay, import logistic regression. Okay, so what we will do now, or should I bring the matrix? So maybe I'll bring the matrix later. Or let me just bring the matrix now. So the same way, I want to also bring the metric. So from sklearn, the import what? Metrics. So the metric is just to evaluate whether the accuracy of it. So let's have it, maybe I can build it as a classifier. Okay, so let's do an instance. So logistic regression. So I'll create the instance here. So anytime I want to run the logistic, instead of me calling it logistic, I'll just call it classifier, or I'll say LR. Okay, LR. Because this is a classification case, that's why probably we just use the word classifier. But if not, any name you call it is fine. Any inequality is fine. So I will now run that. So classifier dot fit. So remember, what are we training? X train and what? Y train. So now we have run it. Now, if I want to see the result, so if you remember the last time when we did the was linear regression, you know how your regression results will appear in Excel. You can also do logistic regression that will come out just the same way, but you need to import that. What's the name of that library we use? What was the library that we use? I think that was import. What is it? Is it start models or stats models? I think start models API as XM. Okay, I think that was the model. So if I want to bring it, what do I do? So that's the model. So what I'm going to do, the challenge with this library is that it does not include the intercepts. You know, when you are writing your model, y is equals to a plus bx. This start model, it does not include intercepts. Okay, so it means I have to manually go and bring in this intercept. So that's just the main difference. I have to manually go and bring in this intercept. But if I want to show you the results, right? If I want to show you the results here, if I check the result, maybe I have coefficients. Let's say classifier dot coefficients. So you see, these are the coefficients. So if I want to bring out the intercept, the same thing, classifier dot what now? I think intercept. Yeah. So this is the intercept. These are now all your y's. Can I see all your y's? But this will not make sense. You know, this does not make sense. So we want to bring it in a human readable form so that we understand it. So in this case, what we can now do, we can now first of all create what? We can now create a constant. So how do we create a constant? So let's say this was our x string. So because okay, let me just do on the x so that we can see it. I don't want to alter my listing here. So I'll just say sm dot add constant. So let me explain what's happening for you. If you look at your x, can you see the x now? Can I see x? Right? These are all my features. Do you notice that there's no constant here? No constant here, is it not? So if I want to bring in the constants, what can I do? I will have to bring constant. So everything now be y, 1, 1, 1, 1, 1, 1. All of them be 1. That's what constant means. So to do that, let me run it now. You see here, there's no constant. So let me run it now. Now look at x now. Okay, it didn't bring it out. So that means what it has done, it has put the constant for you. It has put the constant, but it's not showing you the result as it is because of this. So let me run it now so that we can see how it goes. So if I was to bring it out, I'll just simply say model sm dot what logic. I think is it logic or logistic? Okay, I think logic. Enemies at home. What did they say? See, it's just giving me 1, 1, 1, but let me check what the result is. Add constant. Add constant. Add constant. Let me run it again. Okay. So we have model. Sorry, model equal to sm logic. Okay. Y comma x. Say add constant. So you need add the constant. Let me see. Okay. You know my constant. Let me change to train here. Train here. So here will now be what? Y train. So let me run it here. So let me do it here at Y train, and here will be what? X train. Error. You see, giving me the same issue. It's still giving me the same issue. So let me see. Let's see what the problem is coming from. X3. Phase 2. Data. Let me see. Did I miss anything here? Okay, no, see another thing here. I think this is where the problem is coming from. You know, normally, when you transform this your data, see when you transform your data here, when you transform your data, okay, understand. You know, when you transform your data here, if I look at y, y dot, let's say info, or if I want to check my data type, how do I check my data type? Is it type y? So this is data frame. Can you see that this is data frame? But you see, when I transform x, so let me say type x. Let me try that now. This is a function. Can you see that they are not the same format? One is a function, one is a, okay, I think that's it. I'm sure that's a problem solution. One is a function and one is a type. Let me go and import my data again. Let me run it again. So I'll import that. So I'll run my y, run my x. Can you see that? So x and y. So now here, let me, before I go back to that, just for us to see the result. So let me import this again. My x, so let me add my x constant. So let me run that and check. Is it the same thing? Is it the same thing? So let me now run my y and check. So if I say model is equals to what? Sm dot what? Well, right? Yes, I've run it now. So model will be Sm dot add. Okay, I've added the constant already, right? So if that's the case, then let me just run logic. Y comma x. Okay, I've run my x again. Let me run it here. This is my x, this is my y, this is my x. Add constant there. Now, so that's so where's the problem? This is my constant. Anyway, see, I'll go and look for the problem is not later, so I don't waste our time here. I'll run down this later. But if I have picked the model, so let me run it again. So I've run that. Okay, train test. So let me train and test. But we run it last. Did we run it last time for what do you call it? Did we run it last time for regression? Did I run it for regression?
No.
Run this SM model for regression to see the result. For normal regression, did we ever run it? I don't know where the problem is coming from. Okay, nodes, so train, state, pillar, extreme, okay, y test, okay, run that, regression classifier, okay, Good. So probably let me just leave that, but let me run this to check that around. Okay, so around what we do. I'm gonna check and much later on I don't know what that problem is. Okay. So now we have fixed the model. So the next thing we are expected to do is to go and what do you call it now? Is to try and do the prediction. So if I want to make the prediction, so if you remember, we have what trained this data now. You know we have the test data, right? Has this test data, has it seen this model? This test data, has it seen this model? The test data, has it seen the model? Has the test data, has it seen the model? Has this our test data, has it seen it?
No.
No, it has not seen it, is it not? So you only saw the trained data, is it not? So that training means that based on the model you have seen in the past, based on the model you have seen in the past, it has come up with this as the model. It's now going to use this to now do the prediction. Okay? So we are trying to now predict what our Y. So based on this model you have, this trained data, try and do a prediction for this Y. So remember that Y test is like our actual data. We'll go and do a prediction which will be our Y pred. This is not our prediction. Y predicted Y. It will now give us prediction. So we'll now compare this prediction with the actual. We'll now predict what? We'll now use that to do the prediction. So to run the prediction, I can say Y maybe pred. We now have the classifier. We'll predict. What are we predicting? Using what the X test. Can you see that? This classifier is this one that we have run here. So this model you are seeing here has been captured inside this. Now we want to what predict it using what the test data that it has not seen. So it can do a prediction for us. So that's the prediction. So that's run that. So if I run Y pred now, can I see all these 0, 0, 0, 0, 0, 0? That's 0. What does 0 mean? It didn't predict anything. That 0 doesn't mean that it's not predicted anything for us. Classifier.predict X test. Okay. So probably let me see. It didn't run anything for us. You know all these 0, you know what 0 means? You know all these 0 what it means? It predicted what?
No click.
That means no click. Which doesn't make so much sense. But let me see what they give us. They say X feature has, okay. Do you see this error that I gave us? They say X feature has feature names. What does this mean? What does this mean? X has feature names. What does this mean? They say X has feature names.
Not all figures.
Not all figures, not all figures. So when I was running it here, did I miss? So, oh, I think I removed it here now, right? Y, X, confirm. Because when you are running your model, you must ensure that there's no data. There's no data. There's no data there. There's no data there. There's no data there. Okay. Let me test you. Because once your problem starts from one place, it will just okay, this random. Let me check my Y. Okay, correct. Let me check my Y test. Okay, works. Let me check my X test. Aha. Okay, now it works. Okay, good. So if you have done that, so train test please. Standard scalar. to transform what? X string. Okay. X test. Okay. Give me my model. Run this. Now let me see. I think this is where I'm seeing another problem here. Data conversion one, the column vector y was passed when ID was expected. Okay, let me run this again and check. Run this. Run this. Let me run this coefficient. Now let me run this. Right? Aha. So I think that worked now. So you can see now, right? It has done the prediction for us. So you can now see 0, 1, 0, 1, 0, 1, 0, 1. So probably that when I didn't run one of that line, so because of that, it had text with it. So because of that, you must always do your transformation. Okay, you must always transform them. So it doesn't just work that way. That is why currently now, with things like ChatGPT now, those are now what they call large language models. Now, those ones, they use text. So that's why those inputs you type in ChatGPT, those are text inputs. It takes the input, go through the model, that's the algorithm, go through it and gives you an output. That's the same procedure that it goes. But ChatGPT uses for text. So it falls under what? Unsupervised learning, specifically natural language processing. That's what ChatGPT is. But the same function, it's the same way you build your model. You have the model, train, test, but their own data now is like internet data, all text. If you go to train, based on that training, they will now test and see how accurate it is. Now, what you are now doing, because they are believing the result, they now give it to you. That's why it's now called the deployment. So they have now deployed it. But do you still see that in as much as ChatGPT is accurate, do you still see that sometimes it gives you wrong results? Have you ever observed that? That it also gives you some wrong results. Have you observed that? That ChatGPT also gives you wrong outputs. Have you ever
Yes.
do you see that without, if you didn't have any domain knowledge and you go and use what ChatGPT gives you, sometimes it may be correct, but sometimes the kind of error you give will not make sense. So your domain knowledge also plays a role to know whether whatever output is given to you, whether it makes sense or not. So you can't just take the output of the model holistically, right? Don't just adopt it. So that's why ultimately, in as much as these models help us take decisions faster, but it still boils down to you as the individual, as the manager, to take the decision. Is that clear? So the output, yes, you can rely on it, but there's an extent to which you are going to rely on it. So that's why we need to also test. To what extent can we rely? To what extent can we rely on it? Okay. Now again, if I have done this, I can also check the probability to which I can also rely on this. So to do the probability, to check the probability, we can now do what? Y for right? So I'll use my classifier. So instead of me doing predict, I'll now use predict what proba. Predict what proba. Then I'll now run my what X test. Now, if I run this, let me look at it. So if I say Y prob, so this one is not okay. Okay, Y prob. Now look at this. Can you see your result? Your result in an array. The result in an array. But look at your Y test. Let me see Y test. Y test is the what? Y test is the what? In the data frame, right? What about Y pred? Is in an array. Can you see that? So which means I need to convert all of them because I need to bring them in the table. But they must all be in the same form. Okay? So what I can do here so that I will avoid problem much later, because so I don't want to forget it, I will go and change it here. And remove this thing here. So let me try and run it here. Aha, so in an array form, this is an array form. Okay, good. That one in an array form. So when I want to transform it, I will try and transform them using this thing. Okay, so that's Y-prob. Okay. So which means Y-prob gives you what the probability values. Can I see this probability? So you see, for example, this one is what? 0 means no click. So this one implies that what? There's a 3% chance it's going to click, which is very low. This is about what? 2% chance. Can I see that? This is about what? 14% chance. This is about what? 99% chance it will click. That's 1. So to actually check how accurate this is, you need to go and run some what test. So you now need to go and run some what test. Okay? So this is where confusion matrix comes in. Did we talk about confusion matrix last time?
Yes,
Did we talk about confusion matrix?
we did.
We did, is it not? So you know confusion matrix, what it actually looks at? It looks at what? The actual versus what predicted. This is the actual value, this is what it predicted. Okay? So it looks at the actual versus what predicted. And there are different aspects to it, right? To the confusion matrix. So let me just run it once. Probably let me see if I can get anything on Google. Let me see if I will find anything on Google that confusion matrix. Aha. Okay, good. Good. Say good example. Good example. This is good example. Yes. And I was trying to explain this concept. Aha, beautiful. So can I see this? This is a very good example. Can you see this now?
Mm.
Can you see my screen?
Yes, sir.
So this is the actual. This is predicted. So if you remember, on this side, anything that is 1 means what? The person is pregnant. That's 1. 0 means what? Not pregnant. Can you see that? Anything 1 here means it's true. Anything 0 here means it's false. Right? Maybe like saying not happened. Right? You want to check. Did it actually happen? True. Did it actually happen? False. Then your prediction. Either you predicted 1. 1 means what? Positive. That means predicted pregnant. That's positive. 0 means predicted not pregnant, which is what? Negative. So which means if you are pregnant, right? So if you are pregnant, but you're actually a woman, which means you can be pregnant. So say you are pregnant, that's what they call a true positive. If predicted you are pregnant, but you are a man, can a man be pregnant? Can a man be pregnant?
No.
No, naturally, can he be pregnant? But he predicted that he's pregnant, which is called a false positive. You see that? False positive. If it was a woman, then the implication that she may now be worried if she's not ready for a child, no, she may not be. But if it's a man, you can go to the beer parlor and say, I have no problem. It's not. Same thing with this. You are a woman, if pregnant, you are not pregnant, but actually you are pregnant. It's not. But it's telling you are not pregnant, but actually you are what? Pregnant. That's called false negative. Can you see that? If pregnant, you are not pregnant. The model says you are not pregnant. Actually, you are a man and you cannot be pregnant. This is called true negative. Can you see that? Which means you are noticing that this is actually the accurate one. Can you see the accuracy? So it means your accuracy is what? Your true positive plus what? True positive plus what? True what? Negative. Divided by what? Divided by what? True positive plus what? True negative plus what? False positive plus what? False negative. This is what it calculates for what? Accuracy. I hope this is clear. Which is more dangerous? False positive or false negative? Which is more dangerous? Which is more dangerous? False positive or false
negative?
False what? Negative.
Negative.
Imagine the same thing as COVID. You had COVID. You actually have COVID. Your result said you don't have COVID. That is what they call a false negative. This one can kill you. Is it not? If it was COVID, this one can kill you. But in this case, you don't have COVID, but your result said you have COVID. The only difference is that now you may be worried. You don't buy drugs. You'll be having high BP. It's not because you are worried that I have COVID, though. I cannot go to work. So let me isolate myself. You'll be spending money on drugs unnecessarily. You know, that's the cost implication of it. So you now need to what? Balance it. Can you see that? So that's why I say it depends on which one, but most time this is the one that is more dangerous for us. A false what? Negative. I hope this is clear. So can you see it? False negative. Can you see that? This is what we are looking for. False negative. All right, so let's go and implement it now. So let's go and implement it. So if I want to implement it, I will have to watch, bring in the confusion matrix. And what's the confusion matrix? So I have to bring it from sklen dot what? Matrix. Import what? Confusion matrix. Say no, S. Is it metric or matrix? Matrix. Confusion matrix. So let's do that. So we'll call it, what should we call it? Okay, let's say yeah. CM will stand for confusion matrix, right? So equals to what? Confusion matrix. I'll now test it with my Y test and my what? Y thread. You know why? You know why we are doing this? This is the actual. Is it not? This is what the model predicted. So we are trying to compare. We are now trying to what? Compare. If I run CM, can you see that? But if I want to just bring out the accuracy, so if I was to calculate this accuracy, what would be the accuracy now? It will be 104 plus what? 89 divided by what? 104 plus what? 89 plus what? 4 plus what? 3. What does that give us? What does that give us? What does that give us? Yes, when we do calculation, what does that give us? Okay, so much to add up. 104 plus 89, what did that give us? 104 plus 89. What does that give us?
Zero point 8817.
Okay, the total.
Oh, okay. That's 193.
What does that give us? 104 plus 89, what does that give us?
193.
193, right? 193. So 193 plus 7. Is that it? 193 plus 3, that's 7, right?
Yeah.
What does that give us?
200.
200.
200.
So 193 divided by 200, what would that give us?
0.965.
0.965. Okay, so this is how we calculate manually, but let's also use this to check now. Let's check it now. Because with so I think they also have accuracy score. There's also a form library. So sklearn dot metrics import what? Accuracy score. So to read the accuracy score, so what we can do here, it will be accuracy score. Now Y test and what? So Y test. Remember, we have to predict it. No, we have to predict it. So let's use the classifier. Or I go, or let's say Y trade. I think I've done Y trade already. Is that the same thing we got? Is it the same thing we got?
Yeah.
So can you see that? So the accuracy is what? 96 or approximately 97%, right? 97%. Can you rely on this model? Can you rely on this model going forward? If you want to put in a proper report, then in that case, you have to now put in the classification report. But can we rely on this model now? sklearn.metrics. So can we rely on this model? So if you have trained the model and it gives you accuracy of 96.5%, can you rely on this model? Classification report. So what can do? We can just take class. Can we? Classification report. Y test and Y was great. Okay, if it doesn't look clean, what we can put it say prints. We can look, let me look. Better. So can you see the accuracy about 96%? Can you see that? You see the precision, recall, F1 score. So these are now other metrics, but focus on the accuracy for it. So accuracy of 96%, can we rely on this going forward? Can we rely on this?
Yes.
Yes.
Can we rely on this? You know? So if we can now rely on this, then we can now take it to the next stage. What's the next stage now? What's the next stage? Once they have run this model, now what's the next stage now? What is the next stage? Now you have finished running your model, you have built your model now. What's the next stage now? The next step. Just in case about it, like you're in meeting now, they have built the model, they say, this model is now predicting about 96%. Okay? Are you confident with it? You said yes. So what's the next stage? What do you do as manager now? Next stage. Yes, what do you do? What's the next stage now? Yes, so what will be the next step? It's my wife, yes.
To deploy.
You deploy, is it not? You now have to deploy because you now know the factors that drive whether a customer is going to click or not, is it not? What are those features we are looking at? We are looking at what? Time spent, isn't it? Age, the income, is it not? The daily usage and the gender. Right? So which means we will drive our strategy around what? The time spent on the site. So is there any other thing we can do to make them stay more on the site? Right? Is there any other feature we can add on our web page to keep them there more? Age, is there anything you can do about age? 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 Because you know age by default. So unless you can now go and break age into different age groups and now say, okay, which age group come more? Do you see that? So what we are doing at that point is now what? Feature engineering. We're now creating new variables. From where they call it what? Feature what? Engineering. Why I wanted to use that start model? That start model would have shown us which are the most significant. I don't know why that start model didn't work. Yes. But the next stage is now what? Your deployment. So you now have to what? Deploy it. Okay, so that's the usual last thing. So that's what normally we do with your model. So even the same way with ChatGPT. So they have run it and say that okay, it's about maybe 98% accurate or 90% accurate. So based on that, they can now what? Deploy it. So that's why they put caption is still in beta version, still testing. But every day they are training, they are building, they are improving. Okay, but if it was low, if the accuracy was low, then there are other things you can now do. One, either increase the size of your data, or you look for new variables, new features, or create new features from it. And that one again, you do is what they call hyperparameter tuning. Hey, another big word again, hyperparameter tuning. So they say you are tuning the model, you are tuning it, you are fine-tuning it till it fits the model. Okay, so those are different things you can do when your model is not performing. Now, and that thing again, you know whether your model is performing or not. When you deploy it live, you know this one because I see past data. How do you know whether it's performing even better? You give it completely new data sets. Let it try it and see whether I can predict it correctly. If it keeps predicting correctly, then I can go ahead and what? Deploy it fully. Okay, but take note, as new data come in, you are going to run this process all over again, so that you can make sure that the model is accurate. Okay, so what we can do here, we can just put it in form of what? A data frame, just to bring all of them together to see what it looks like. So maybe I can just say pd data frame actual. So what's my actual data? I think that was my Y test, right? My Y test. What's my predicted? My predicted was what? I think Y test. Then last one is what? The probability. The same way you can even deploy it for like HR attrition. Which employees are likely to leave? Remember, likelihood, these are probabilities, likely to leave. They have not left, but the model can predict that whether they are likely to leave and what percentage they are likely to leave. Y prob. What's the problem? Okay, I'm putting it in a dictionary. In a dictionary. Yep. Enemies are there. You see, data must be one dimensional.
If maybe
Now, why is that happening? If you check my shape, right? How do I check shape? Why? So I check y test dot shape.
tomorrow.
Can you see that? If I check y what? Thread dot shape. See, they are not in the same level. They have what? Y what? Which one is the other one? Y prob, right? Y prob dot shape. Can you see where the problem coming from? Y test. My Y test. Let me check Y test. Y test was the data frame. Guys, that Y test was the data frame. For my Y prob, or my Y prob, they were not in the same form. Can you see that? So what do we need to do? What do we need to do? Now I have to work to shape my Y test. So they will all be in the same form. I have to now reshape it to be the same form with this. So how do we reshape it? You see where NumPy now comes to play. You will now see where NumPy has a role to play here. Okay? You see where NumPy plays a role here. So those reshape that we are learning that time, this is where you see it comes to play. So it means why it's work now.
You want to see your dear before you get down there. So we still
Should I go and pick her?
See
the key here.
See
your key.
I'm coming.
We mentioned it won't budge or smear. No matter what, creating the perfect permanent eyeliner.
All right, so let us reshape it. So how we reshape it? So it will be NP dot what? Array.
Effectively to ensure it still
I said, I want to shape it. I know, so I'll say what? Reshape. Reshape to what? I don't want the first one. No, so I'll reshape it. So let me run it again, okay? Y what? Yes. Okay, good. So Ghana is the same format. But two. Okay, Ghana is the same format. So now I can make them together. Now I can make them together. This is it. Can you see that? Can you see that now? So this is my final result. This is now my final result. So if I want to now send this my file to what? Maybe an Excel file or a CSV file. What do I now do? I can now write it to what? An Excel file or what? A CSV file. So I can just say final dot to CSV. Let's call it what? What should I call this? Let me just call it what? What should I call this file? So let me just call it final prediction. I even want to make it Excel. I think I can also make it Excel, but yeah, maybe again index. I don't want any index. So index equals to false. Index. That's how you have run the full model. So let me look for what I call the file, final prediction. So let me look for it. Final prediction. What is in my final prediction? Can you see my file? Can you see the file now? Final prediction. Can you see that? So imagine I had maybe like, assuming this was employees, these were different employees. These are the ones that have left. 0 means still in the office. 1 means they have left. So if we now decide to now do our prediction, let's highest to lowest. 99% is what? Put in percentage terms, what does that mean?
We also ensure no lines
Look
so
into
the
two decimal
pigment
places.
doesn't migrate. So beautiful.
So this is almost 100%, right? So this is 99.99%, but you has already left. If you're there correctly that you have left. Can you see that? You're there correctly that you have left. So which one will be more important for us? Is it the ones that have left or the ones that have not left? Which will be more important for us? Let's assume this was we are predicting employees that have left. We have a model like this. What will be more important for us to check? You know, one represents what? One represents what? The person has left, is it not? Zero represents the what? The person is still what? Still working. So which one is more interesting for us? Is anybody in HR here? Anybody in HR here? Nobody in HR. So, well, let's think about it. Let's assume it was the HR who have predicted employees are likely to leave or not. Which one will guide us to now know?
Zero.
Huh?
Those that are not, those that
Zero
have
means
not.
what? Not still working, is it not?
Yeah.
So, actual is it not? So I'm going to filter the data to what? Actual. And still working, is it not? And remember, one means what? It has predicted that what? He has left, that is going to leave, isn't it? So which means, I hope you understand this, zero means what? They are still working with us. They are still what? Working with us. Why this predicted is not is showing that the model is saying this guy is still working. But there's what? 85% chance that he's going to leave. You see that? This one is saying he's still working. There's 61% chance he's going to leave. Can you see that? This one is showing that he's still working, but there's a 50% chance he's going to leave. So what it means is that it has helped us identify at least these two. There's a high chance that what? They are likely to leave. So what do we need to do? What do we need to do? What do we now need to do? What do we now need to do?
Find replacements.
Either find replacement or what else do we need to do?
Speak to them.
Yeah? Speak to them, is it not? Speak to them. But you see, at this point, you cannot be telling us that it's more than I told you. Right? Because now you now need to now implement practically. So what are those things that we should do to what keep them? Can you see where when you are building models, your domain knowledge is key. Your knowledge in math and statistics is key. Your programming skill is also what important. And this is what makes you what a complete data scientist. So if the model is the list of your problem, it's now what the problem you are trying to what, solve. So what are those factors that we have looked at that may make an employee leave or not? So we now look at several of those what factors. Now we have identified those ones that are likely to leave or not. But in this case, it was click. Is it not? But HR will have been more relatable for us. So with this, we can now what quickly identify what we now need to do. Then now see that okay, based on this model that we have seen, we can now know what strategy we now need to put in place to start keeping what setting. Especially where the challenge will be, especially if these ones are what have what they call key man risk. Is it not? They are in particular department and they are alone. That can be what a key man risk. I hope we can see how machine learning models can guide us in strategy.
So for us as manager, this is the list of your problem. Those codes are the list of your problem. Is the output of it that's what should be important to you? I hope this is clear.
Yes, sir.
Are we clear with this?
Yes.
Yes. Any questions so far? Any questions so far? No, okay. All right. So what we have been doing, we have been what? Building machine learning. Although the other algorithms we'll talk about, but what I want us to do now, before we leave, I want us to do a bit of data cleaning and data transformation. You know, so far we have not been cleaning data. We are just assumed that the data is clean. But I can guarantee you, 100% of the time, there must always be problem with data. Okay? So you will need to what? Clean and what? Transform that data in a form ready for what? Analysis. That's why when I was trying to run the model, as long as I had a feature there, any text, it cannot run. So we need to always what? Clean and what? Transform it. So let us show how to what? Clean and transform data. Okay? How to clean it. Did we do data cleaning in Python? Have we done data cleaning in Python? Chino here?
Yes, sir.
You do data cleaning in Python?
We have.
So what aspect did we touch on?
We took out blanks with the NaN and lights. I know that we took out
Okay, but
column.
this one, did we use real data or we just created a small data frame?
No, we sorry?
I said we use a live data or did we just create a small sample data?
No, we used the live data. We didn't create a small sample.
Oh, okay. That's fine. So maybe then the only thing we can just talk about, for example, let me see. Which data set can we use? Okay, maybe okay. So since we have done that, since we have done data cleaning, maybe we can go a bit more advanced in data cleaning, right? Because so can we clean something like this in Python? You see, like this data set now. You see how bad this data set is. Can we clean this in Python? Can we clean this type of data in Python?
It's possible.
It's possible. It's possible, right? Yes. So if we are to clean this now, what do we do? Where do we start from? If we are to clean this data now, where do we start from now? Where do we start from? We are to clean this data now. Where do we start from?
Between the rows and columns, the empty rows and columns.
Yeah, so you can take all those empty rows, empty columns, not. You can take them away. Those empty rows, empty columns, you can just take them away. Okay. All right, you can just take them away. So let me quickly try and import this data so that we can see how we can clean it. But we'll try and clean a lot of things because if we have done data cleaning, I'm sure we just remove empty rows, empty columns, right? Did we do transformation on pivoting?
Yes, we did.
We did on pivoting.
Yes.
Okay, so that means we cleaned this type of data already now.
Yeah, I think so.
Or we did that already.
But they have done that already, then that makes it easier for you. That makes it easier. That makes it easier. Okay. So probably let me try and use any of that I just made. Okay. So let me put this in text. Let me draw that file. Let me insert that file. Because the file is located, I want to use the old file. Do we talk about one hot encoding?
Sir?
Do you talk about one hot encoding? One hot encoding.
I don't think so. No, I don't remember that.
Do we talk about dummy variables?
Dummy. We mentioned variable.
Dummy variables. Do we talk about dummy variables?
I'm not certain.
Dummy variables. So normally, so let me see. Let me go back to that. Where's our data? Let me, you see, for example, can I see mail? Can I see my screen now?
Yes, sir.
You know, normally this data, they would have written mail, email. Can you see that? You see that? They have been written mail, email. But I cannot use mail and email to run analysis, to run machine learning. So what do we need to do? What do we now need to do?
Assign number to them.
You have to now assign numbers to them, isn't it? So we are now assigned, for example, if I'm interested in just female, so female 1, otherwise 0. This is called what? This is called what? A dummy variable. Do you understand that now? That's what it's called.
Yes.
It's called a dummy variable. Okay. So because you see that when running machine learning models, all those your text that you have in your model, all those texts, you have to look for a way to what? Encode them. So we now talk about what? Label encoding. So label encoding simply means what? Label encoding means what? What does label encoding mean? Label encoding. What does label encoding? What does it mean? Label encoding. Yes. What does label encoding? What does it mean? Label encoding. Let me see a typical example here. Do you have anyone that is label encoding? This one has already been done, right? This one has already been done. This one has already been done. Let me look for another data set that we can use. That has not been included. Okay, there's usually this Titanic data set. I think that one will explain some concept to us. So let me try and use Titanic data set. That one will explain some concept for us. Titanic data set. Okay, let me share. Let me see.
is a part. Let me just try. So I can just explain. Since I've done a lot of cleaning, let me just explain this thing. Because a DF is equals to ED.read.CSV part. Can you see the data now? You see like male, female, can you see that? I cannot use it to work. So what do we need to do? We need to what? Convert it. Can you see that? We need to convert it. Okay. But you know, most times, even before you say you want to convert it, you must even check. You must even check whether the data has even like missing data and the rest. So you must even check whether the data even has missing data. If it has missing data, you have to now check. If there's data, remove the missing data. If there are duplicates, remove duplicates, right? Which other data cleaning did we talk about? Which other data cleaning did we talk about? Which other data cleaning did we talk about? Which other data cleaning did we talk about?
Blocking of scenes. Yeah.
Which other data cleaning did we talk about? If I want to check whether the data has missing data, what do I do? If I want to check if data has missing data, what do we do? If I want to check if they are missing data, how do you check missing data? Because you know, once you have imported the data, you need to check whether they are what missing data. So how do you check for missing data? So how do we check for missing data? So for example, if I have df dot what is null, right? Guys, I tell me true, false, true, false, true, false. Anyway, you see true, true means missing. False means not missing. So if I want to put it in numbers, I can put either in sum. So you tell me that age has 177 missing data. Cabin has 689 missing data. And Bact has 2 missing data. If I want to check them like in percentage, then I will do it in terms of mean. So 77% missing data, 19% age has missing what data. Can you see that? But if you want to now, for example, you want to check, okay, of all these missing data, which are the ones that are the most? So you can do like rankings. I can have something like df dot what is null dot mean. Then I can now sort it. You know, so I want to say sort values. Sort values. Is it ascending or descending order? I want to do it. The highest should come first. Should it be ascending or descending order? Sort value, should it be ascending or descending order? Should it be in ascending or descending order? Yes? Should it be in ascending or descending order?
Ascending.
In ascending order. Is it in ascending or descending? You know, ascending means from lowest to highest. You know, so we want to see from highest to lowest. So what will it be?
Oh, okay, descending.
Descending order. So you said, you know, by default, all software will have ascending order. True. You know, so here you have to put it as false. No attributes mean. Sorry, it's null. Sorry, it's null. It's null. So can you see that? So cabin has the highest, followed by what? Age, followed by. So if I want to drop a particular one, I can either drop it. But for example, what's that now? What do they call it now? You see, like age. So age, what I want to do, I want to fill age with the median value. So how do you fill age with the median value? So I'll say age will be equals to what? df dot what? Age dot what? Fill any. Fill any means fill with what? With this thing. So I want to fill it with what? What am I filling it with? The median. So age dot median. So I'll run that. So if I run df now, do I expect to see missing data in age now? If I run this, should I see missing data in age? Now that I've
No.
So if I run that now, can you see age has no missing data now? Can you see that? Age has no missing what data. Look at embarked. Embarked also has missing data, right? Where's embarked? So can you see embarked? But it's very few. So if I want to see the unique values for embarked, what do I do? It will be df embarked dot what? I can say n unique. N unique. NaN, what is NaN? What is NaN?
Not a number.
Not a number, like you know how Excel just will leave it as blank, as null, you know. So which means I don't want this. So it's like a blank data there is blank, right? So what do I want to do? I want to fill it with the highest frequency. Which one is the highest frequency now? To check highest frequency, what do we do? If you want to check the one with the highest frequency, what do we do? We can do df what? Embarked dot what now? Is it value count? Value count. Is it value count or value count? Which one has the highest frequency? Which one has the highest frequency? Which one has the highest frequency?
Yes.
Yes, you know. So what do we do? We are going to fill this blank one with what? With the S. Can you do that? So when you have text data, you fill it with what? With the highest frequency. If it's quantitative data, you fill it with what? Either the average or the median. But to be safe, always use the median. I hope you understand that. So which means you have to go one by one, look for where I have that missing data and fill it. So what can we do now? We can have df embark. So this is where all those basics of Python come into play. Because we now have to clean the data now. So we can either apply it. I can just apply. If I want to use one line of code, I would have created a function. But we can create it in a line of code. So I can use what the lambda function. Lambda. So let's say lambda x. So dot what? Fill it with what? X. Dot what? Value what? Count. Value count. Well, if I don't want that index, I can complete index 0. Let me see. Columns must be the same length as key. Column must be the same length as key. Let me see. So df dot what? Apply ahead, lambda, okay. Pn here. Value count. Let me remove this size. Columns must be the same length as key. Let me run that again. Df. So what we have here? 891.
Okay, here when we embarked on, so let's do this again. So df.info. Okay, df.info does not even bring it up. So okay, it's there now, 891. So embark, okay, look at, can you see it? Embark. This is the problem. What we are using is 891, but here is 889. Do you see that? So I'm sure that's why it's giving that error there. What else can we do? Or even at that, you're not supposed to still pick it. You're not supposed to still pick it. Okay, which other method can we use again? What other method can we use again? I want to see if I can use that lambda. But what other method can we use? Okay, see what I can do. Eh? We can also, maybe can I see if I can map it? Let me see if I can map it. Or can we drop? If I say df.drop any. This drop any, what does it do? Drop any. What will drop any? We only drop any, we go and look for all data and drop it. So that one is more dangerous. That is more dangerous. That's more dangerous. But because I want to change it, so what we can do, we can just simply map it, right? So I can use map. Did we talk about mapping? Have we talked about mapping before?
Yes, we mentioned mapping.
I mentioned mapping. So for example, you see that male and female, how we assign 1 and 0 to gender, isn't it? We assign 1 and 0 to gender. So that's mapping. So we can, let me just map gender, then we'll come here and map and back. So what we can do there, so for gender, so I can have df. So I want to map it, so I'll have df dot map. Okay. So which one do you want to map? Do you want one male to be 1 or female to be 1? Which one do you want? The one of interest is the one you put as 1. You see that? What your interest is the one that is 1. The other one otherwise 0. So which one am I more interested in? In this Titanic, who is likely to survive? Is it male or female? Who do you think will more likely to survive, male or female? Who will more likely to survive, male or female? Female, is it not? Because they tend to rescue female, is it not? First before the male. So in this case, we're interested in what female, isn't it? So since we're interested in female, what do we do? We now change it now. So we're going to change what? Female. Please make sure you spell it exactly the same thing, because Python is extremely case sensitive. So where is female? Assign 1. Why what? Male. We are going to assign what? 0. If I run df now, can you see how this was transformed? In that other one, how it was transformed. So it was, but in their own case, they assigned male for 1, female 0. For this one, embarked, it means that I can do the same thing. Embarked, df, embarked, dot map. So I want to map it. So here where I have maybe S, I will give it maybe 1. Can you see that? Maybe where I have what? Is this C? I will give it 2. While where I have what? Q, I will give it 3. So if I run that now, df. Can you see how it is?
So that has been what assigned. So can you see how you transform the data? Can you see how the data is transformed now? So this is how you usually would transform your what data. Okay, this is how normally you would transform your what data. And that way again, you have also what we have done here, we did it manually. We did it manually. Let me import the data, that data again. So let's redo it again. Let me import this data manually. Now, whenever you are working, they always try as much as possible create a backup for your data, so you don't have to go back to always start importing it again. You get, you don't always have to go back and start importing it. So this is my path. Okay, if I say df is equal to pd dot use path. That runs. Okay, pd dot read dot csv, right? CSV here. Node. So right now, where that one we had drawn, where we had cleaned it up. Okay, let's just do it. So let's do the same thing. You see what we have done for male and female, right? We have to transform it male and female. So we are going to use what they call dummies. So let me put this data frame. So I'll say pd dot, so in your pandas, there's something called get dummies. What variable are we working with? If I run dummies now, can you see what that's done? Can you see what that's done? In this case now, male 1, female 0. Can you see that in this case? In this one here, male 0, female 1. That's exactly what we have done where we have drawn it here. Where is it? Can you see this one? In this case, we have used female. So that is what I have done. But if I want to go and merge it with the original table, if I want to now bring it with the original table, we now have to what? Merge them together. We now have to bring them together. So what we can do, I can just call it maybe let me just call it df, or let me just call it data, right? Equals to pd dot what? Concat. What is concat? What does concat mean? Concat. What is concat? Like join the tables together, isn't it? So pd dot concat. What are we joining? We are joining what? Our original data, df, and we are joining this our dummies data. Where are we joining it on? We are joining it on the column. That's add is equal to 1. So if I run data now, can you see it now? It has now transformed it. It has now what? Transformed it. So this is what sometimes you call your one hot encoding and the rest. Okay. But there's also another one they call label encoding. Label encoding. Maybe probably we can do that next week. Maybe we can do that next week. But we're trying to see how we can round up so that we can enter other things. Okay, so probably what will be left for us. So maybe we can just do one data cleaning, especially this transforming data, right? How to transform the data, how to use your one hot encoding. Because in this case, there's something they call dummy variable trap. Dummy variable trap. If you look at male and female, if I merge them together in 1, do you notice your everything will be 1, 1, 1, 1, 1, 1. And your constant again 1, 1, 1, 1, 1. When you try to run that, it will give you an error. So it's called a dummy variable trap. So normally you only choose one, so you drop one of the dummies. So probably I think that's what we are going to look out for. So I think what is left for us in Python there? What is left for us in Python? apart from cleaning, so we look for a machine learning model, we will clean and transform it, build the model. Okay, so that's what one thing we'll just do. Then another thing we can look at again is some other machine learning models and algorithms, such as KNN, naive. So we'll look at all the classification models, then how to run all the other classification models. So I think that with that we can end it there. I think Chinere, that will be fine.
Okay, sir.
I think that will be fine. So if I just do, I'll just run us through one full machine learning model from transformation to the prediction. Okay. Then show us all the machine learning models, how they are being applied. Then that's all. Okay.
So does that mean next week concludes machine learning?
I hope we can conclude it next week. Yes, we can conclude it next
Okay,
week.
sir.
We can conclude it next week. But you see, even when we conclude it next week, with that is okay, right? But you see, in the real world, when you want to start doing real jobs, there are 3 other skills you are going to learn in addition to this. So once you have built the model, the next aspect is deployment, right? So you have to look at how to deploy the model. That's one. You see this data cleaning that we are talking about. You will need to also learn regular expressions. That's a very critical skill you must learn. Then another one again is when extracting data. Most time this data was given to us. Most time you need to also extract the data. So you need to learn how to extract data from a database inside Python. Then run SQL script inside Python. Then you also need to learn web scraping. Can you see that? So web scraping, connecting to a database, regular expressions to clean that data, and deployment. So those are the 4 aspects. Once you are done with that, then I think you are okay. But we may not be able to do everything, but I'll just teach up to next week, maybe up to a full machine learning model. So we'll look at how to implement some other machine learning models. Okay. So once we are done with that, I think.
Sir.
So if we don't finish next week, but upper week we should be clearly will be done by upper week.
All right, sir. Okay, sir. Okay.
But the challenge is that subsequently, then we now have to bring maybe guests, guest facilitators, those that will now come, those who have been working in industry now, who will now explain to us how deployment works, how web scraping works. But if we have anybody here that can also teach us that will also be fine. Deployments, web scraping, what again did I mention again? Regular expressions. Okay. Maybe connecting to database. Maybe I can illustrate that quickly, because that will not take time. I can illustrate that quickly. But that will be fine. That will be fine. All right, guys, let me join another session. Is that okay? So we'll see next week.
Thank you, sir.
Thank you.